All right, so in chapter 5, what we're going to do is we're going to kind of continue our work with graphs that represent quantitative data, but we're going to introduce one, the box plot, that'll allow you to do a lot more than you might be able to do with a histogram. And really that boils down to comparing. First of all, what we want to get a definition down for, just so we have it, is the 5-number summary. So if you take, and this is something we saw when we did the one variable statistics in our calculator, we had the minimum value, the quartile 1, the median, the quartile 3, and the maximum value. That's called collectively, that's the 5-number summary. And basically, well, the min and the max are pretty basic, easy to understand ideas. The median is smack dab in the middle of the ordered data set, and the quartile 1 is the middle of the lower half of the data, and the quartile 3 is the middle of the upper half of the data. And it breaks it into quarters, hence quartiles. And what we're going to make out of that is a box plot. And a box plot's a graphical representation of the 5-number summary. And it you might have seen it before in another class, possibly introduced as a box and whisker plot. Both of those terms get used, but usually in this text it's just referred to as a box plot. And the big advantage with box plots is we'll be able to easily compare multiple quantitative data sets. If we wanted to just look at a singular data set in the form of a histogram, there's lots we can tell from the histogram. If we want to then pull different groups out of a larger group and look at them separately, looking at a bunch of separate histograms isn't as helpful. So the box plot is much more helpful for that. And all this we're going to do in this lecture is we're going to just talk about making it, because this is one that, yes, you can use the calculator. The calculator will do it for you. However, this is one that it's easy enough to do if you're given the 5-number summary. It's easy enough to make one that it could show up on the test. So you're going to want to know how to do it by hand, even though, yes, the calculator will do it for you, and we'll go over that in class. Right. So first things first, we're going to use you're going to be given the 5-number summary, as is often the case. When you're being asked to make a box plot, you're going to be given the 5-number summary. And the one we're going to be using is from page 81 of the textbook, the second page of chapter 5. And it's the average wind speed for average daily wind speed for 1989, for the year of 1989, in, I think, Woods Hole, Massachusetts. Maybe. Nope. Anyway, doesn't matter where. All right, so we've got the 5-number summary, and there it is. So the average, the highest average is 8.6. Quartile 3 is 2.93. The median is 1.9, and so on and so forth. And we have it all given to us, which is, like I said, often the case. So step 1 is we're going to create a single axis spanning the extent of the data. It doesn't matter whether it's horizontal or vertical. The calculator is often times is going to give, or you're going to be working with horizontal box plots. I think more often than not in the test, the space they give you, and they oftentimes give you kind of a little bit of a grid section, is horizontal as well. It doesn't really matter. You're going to do the same thing. But the first thing we're going to do is we're going to create that single axis, and we're going to use these middle 3 values to create the box, Q1, the median, and Q3. And so here's our, we'll take our number line here, and we'll, sometimes I will give you the graph, the line, or I'll put it on grid paper, so it makes it a little easier for you to actually do it out. You do want to space it out fairly evenly as best you can if you have to do it by hand. But they are going to recognize that you're doing it by hand. Okay, so I've got it right there. Now, we're going to take our values and So we're going to put the median at 1.9, so that's almost 2. So I'm going to, in this case, I'm going to put a vertical line right here. The minimum is almost, or Q3, I'm sorry, Q1 is a little over 1. And then Q3 is almost 3. It's 2.93. And so there's our box. Q1, our median, and Q3. That makes our box. Okay? There's our central 50%. There's where 50% of the data is going to lie between 1.15 and 2.93, which is kind of our we did that when we're talking about our IQR, which is the spread for a skewed data set, which we're going to come to find this is pretty skewed data, even when we're looking at it from the box plot. Next, this is important. We're now determining what an outlier is, right? And we're going to create what are called fences. Now, it's important to note, and the fences are just the cutoffs for beyond which outliers lie. Okay, so if we're looking at we're going to create an upper fence and a lower fence. So the upper fence is this one right here. So you take the value of Q3, 2.93, plus 1.5 IQR. This is the only time where you're actually going to take the difference of the IQR and find what the difference is. Right, so we're going to take 2.93 and subtract 1.15, and we're going to multiply by 1.5 and then add it to the third quartile, and that's going to give us 5.6. Right. Now, anything beyond here, I'm going to just change the color here. So 5.6 is a little bit. So if I just draw this here, got a fly bothering me. So if I sound a little distracted, I might be. Right. So this is our cutoff here. This is our cutoff for any high outliers. All right. And then we're going to repeat the process, even though we don't really need to, do we? Because our quartile 1 is 1.9 minus 1.5 times 1.78, right? And that's going to be a negative value. So we're not going to have any low outliers, but we do have a high. We do have at least one high outlier, right? Don't bother putting the fence in because it doesn't. We don't have any negative values. So this is not part of the graph per se, right? But it's just it's the border of outliers. Okay. So we've got our box. We've determined what values are outliers. Anything beyond 5.6 on the high side, anything below negative 1.52 on the low side, which in this case is not not going to be an issue. You can have negative wind speeds. Now we're going to extend the whiskers, right? Now we're going to extend the whiskers to the largest values within the fences. Okay, so we'll do the low end first because we have that, right? The most extreme, I guess largest to the probably most extreme is probably a better way to put it because it's not always largest, right? It's the most extreme value. So if we do the low end, the minimum value falls within the fence. The minimum value is not an outlier. So we're going to extend the whisker to just a bit above 0. Right? Just about 0. Now here on the other side, our largest value is an outlier. The maximum value is an outlier. So we're going to extend the whisker to the fence. We're going to stop. And we stop because we don't know. We only know 5 numbers. We don't know what the values are, right? But anything beyond that is an outlier, right? So there are our whiskers, right? And so that's our min, right? Q1, our median, our Q3, right? And this isn't anything. This value here is not the maximum value. We're going to have to do something special with the maximum value because any values beyond the outlier, beyond the fences, get special symbols. Okay, so our outlier is going to be 8.67. Right, so we're going to put an outlier right here. Right, it can be an asterisk, it can be a dot, depending on what you have. Right, this is our maximum value, which happens to be an outlier. There might be other values in between here. We just don't know what they are because all we've been given is the 5-number summary. Okay. So now we have our box and whisker plot, and the distance. We have 25% of the data falls between 0.2 and 1.5. 25% of the data falls between 1.5 and 1.9. I'd write it in, but it would just mess up the graph. Another 25% of the data falls between 1.9 and 2.93 right here. And then this whole distance here from Q3 all the way to the maximum is the remaining 25%. We don't know what this cutoff is. We don't know that this represents 25% because the 5-number summary is these values here: the min, quartile 1, the median, quartile 3, and the maximum. Okay. So we do know that this data here, this is the box plot that corresponds to this 5-number summary. Okay. So we start with the box, which is Q1, median, and Q3. We then determine what are outliers, and we use those two formulas, Q3 plus 1.5 IQR and Q1 minus 1.5 IQR. You have to show this work. This is something you show, right? This is something that you show. These numbers did not come out of nowhere, right? You have to and now that we know this, now that we know how to determine what outliers are, we no longer are saying possible outliers. We're saying outlier. We're making more definitive statements because we have those cutoffs. Okay? So we determine beyond what values do the outliers lie, and then extend the whiskers. If everything's within the fences, there are no special symbols. There are no dots or asterisks. Right? Dots and asterisks only exist if there are outliers. If the maximum and the minimum values are within the fences, then that's where the whiskers go to. For instance, if the maximum value was, say, 5, this whisker here would only extend to 5, and it would stop, and this would not be a value, right? But it didn't. The maximum value is 8.6. Okay, so that's just creating the box plot. Hopefully we can get this down now in our notes, so when we get to class we can start analyzing them. We can start using them to make some comparisons between distributions, and also how to go through them and do them with the calculator. All right. Ran a little long. I apologize for that. Please let me know if you have any questions. Hope this helped.